Hey, welcome to my channel. This is the first video of a series in which I'll be covering Anime.js, which is one of the greatest animation libraries to have ever been created. This library is the biggest competitor to GSAP in terms of what it is capable of creating. In addition to that, Anime.js is 100% free to use, whether it's for personal or commercial use. So, to create an animation in Anime.js, we need to use the anime function and then pass in a variety of configuration properties. First and foremost, we need to provide the targets property, which refers to the element we want to animate, and then the CSS property we want to change, so it creates the wanted effect. The value of the targets property could be a string that has a single CSS selector, such as an ID or multiple selectors separated by a comma. It could be also an array holding the different selectors. As I said before, it could be any CSS selector, so in this case, any element with the class name squares will be animated. We can also set a DOM node or a node list as a value for this property. Last but not the least, we can animate numeric values inside objects. Therefore, we need to specify which object's property to animate in the anime function and set the values to reach after the animation's end. With Anime.js, we can specify almost any CSS property. We just have to use the camel case style when we specify the property's name in the anime function. That said, there's a minor difference when it comes to CSS transforms. So here's the list of the different transforms names if you wish to use any of them. Along with CSS properties, we can also animate any DOM element that has a numeric value, such as an HTML input. Finally, we can make use of Anime.js to animate SVG elements in order to create some interesting effects, such as morphing shapes. To do that, we need to set the points property with the new coordinates of the points. You have to keep in mind though that the shape must have the same amount of points in its different forms. There is a variety of other important properties besides the one that I have already covered. The first one is duration. By default, the duration is set to 1 second. That being said, if you wish to make longer or shorter than that, you should specify the value of this property in milliseconds. Delay sets a delay before the start of the animation. There's also the end delay property, which sets a delay right after the end of the animation. As you might have noticed when I tried to animate numeric values in the previous examples, I used the round property, and here's why. As you can see, using round makes it so the values are rounded up to decimals when they are getting changed. We can set each property parameters on its own, its duration or delay for instance. We just need to set the parameters in an object, and within it we set the value property, which contains the actual value of the change. Values of the properties can be set dynamically through functions. We can use these functions without any parameters as long as they return a value, or we can specify three parameters on which depends the value returned by the function. So, let's say we have a list of elements to animate that have a common class, and we want to go through them one by one. Element represents the current animated element within the list. Index represents the index of the element. And finally, length represents the length of the list. The direction property works in the same exact way as the CSS animation direction property. We can use it to reverse the animation or create an alternation of the effect. We can set the number of occurrences of an animation through the loop property. Thus, we can specify a certain number or set it to true for an infinite number of iterations. We can make multiple variations of an animation through both of the direction and loop properties. Autoplay defines if the animation should automatically start or not. The next property we have is easing, which adds realistic effects and feel to the animation. There are multiple easing functions, so let's start with linear, which in fact negates any easing effect. The second easing function is steps, which breaks down the whole animation into a number of steps, creating a Tetris-like animation. To find some really interesting functions, you can check Easings.net, which has a lot of them, including what's called pinner functions and elastic easing functions. We can as well create our own cubic Bezier curves through some websites like this one, where we choose how the overall animation should look like, making use of this small graph, then just copying the code from the text box into our code. There is also spring, which is a physics-based easing. This function has four parameters, which are mass, stiffness, damping, and velocity. Lastly, we can create custom easing functions based on the three parameters that I talked about earlier, and also another one which represents the current animation's time. This variable belongs to a nested function that is returned by the parent one instead of a value. If we don't explicitly set a values unit, it will be added automatically. In case we have the value in a certain unit in CSS, if we use another unit in the enemy function, the unit will be converted to the one used in the enemy function. We can add, subtract, and multiply values relatively to the original one. In this case, as you might have guessed it, the width of the squares will be the original 60 pixels plus 200 pixels. Setting the values within an array will force the animation to start from the first value in the array, therefore ignoring the one specified in the CSS code. We have the choice between different representations to set color properties. In fact, there are 5 representations, which are hexadecimal, RGB, RGBA, HSL, and HSLA. This should be enough for this first part of the series. Make sure to subscribe so you don't miss the other upcoming parts, and see you in the next one.